Hey everybody, it's Tuesday, it's 3 o'clock, and that means it's Tech Tuesday. I'm Rick Yuzzi, and today I have a special guest, and we'll be talking about G.hn. I'll be right back. Thanks for joining me. I am Rick Yuzzi, and again, I'm here today with a special guest, Livia Rosu from HomeGrid Forum. Livia, how are you?
Hi, Rick. Thank you for having me.
Yeah.
Wonderful. Thank you.
Yeah, thanks for being here. And actually, we're talking to you all the way from Spain, right? So.
Yes, indeed.
Yeah, so we have a good connection, can hear you, no issues at all. So again, you're president of the HomeGrid Forum. So why don't you tell us a little bit about what that is? Now that's an industry group, right? But what is that group? And then tell us a little bit about G.hn as well.
Thank you for asking that question, Rick. HomeGrid Forum is an industry alliance. It is an industry alliance composed of silicon vendors, system integrators, system manufacturers, service providers, and all different players that are committed on deploying G.hn broadband connectivity.
Mm-hmm. Now, I noticed you said G.hn. Is that what most people say? So instead of putting the dot in there, they just call it G.hn?
Another brilliant question. Some people would call it G.hn, some others call it G.hn.
Mm-hmm.
We are using the dot in the G.hn as a way to reflect the connectivity that is actually placing an important role, having all the CPEs connected in the home, outside at home, providing home connectivity and broadband access connectivity, extending the connectivity. So the dot in our logo is actually moving as a way to extend the connectivity.
Okay. So let me kind of give a summary of what it is, and maybe you can expand on that. So this is, you guys say any wire, anywhere, right? So basically what you're saying is that with G.hn, somebody can use the existing wiring in a home or a building, and they can use twisted pair, copper, and I think even, was it plastic fiber? Is that right? Different types
Indeed.
Of wires?
In the G.hn technology, it is a standard technology developed by ITU, the International Telecommunication Union, which is the standard body that has developed a specification for the gigabit, multi-gigabit broadband connectivity. And we do deploy G.hn over powerline, phone line, coax, and plastic optical fiber, what we call POF, indeed. So it does work over any wire. It is extending the wired connectivity. That's why we call it any wire connectivity. It is used as a mean to actually extend and reuse the existing infrastructure so that whatever we have deployed already in users' homes, we do not need to make any extra holes in the walls. We can reuse what has been already installed. Any wire.
Mm-hmm. So, and was that the original use case, was as a replacement for, to be able to do home networking, a wired home networking connection?
Indeed. And this is why actually the G.hn stands for, because the original name of the specification was Gigabit Home Networking.
Okay.
And it has been used as such ever since. It has been branded as such, as a specification of the ITU. And HomeGrid Forum is the organization, the industry alliance that is helping ITU to promote, deploy, and certify devices that are embedding G.hn technology. Initially, they were used for home networking connectivity, indeed, as you correctly said. Then the use cases have been extended to cover a large variety of topologies. So it followed by broadband access. What we mean by broadband access, it is using the connectivity outside the home, and we can extrapolate on that. So when you have the fiber connectivity getting all the way to users' homes, or the fixed wireless access, and then by some reason that cannot reach every single subscriber, then is using G.hn. So that's what we call the broadband access connectivity. But then it went beyond that to actually work in combination with Wi-Fi, what we call the wireless connectivity, and then in combination with applications that are very much specific for Li-Fi applications, so using light waves, not just not just the frequency spectrum, but light spectrum. And then it went beyond that to actually address applications like smart grids, smart cities, for the smart metering and energy consumption in users' homes. And last but not least, industrial applications, the industrial revolution, robotics, factory machines, and so on. So it really has addressed an impressive evolution of use cases and topologies.
So yeah, so Internet of Things would be something that would come to mind. I was thinking, with a video camera that I've got outside, it plugs into an outlet outside. It's connected via Wi-Fi. But every now and then, it's kind of on the fringe of my Wi-Fi, so every now and then it'll kind of go in and out. So if I had a device, like a video camera that had G.hn incorporated in it, then it could use either, I guess, the Wi-Fi or the power line, actually do it that way?
Indeed. The IoT devices can have power line embedded, G.hn power line embedded, and the video cameras for these specific applications. For the video surveillance, are IP cameras using G.hn over power line. You actually plug in the IP camera and you have both the connectivity, the gigabit connectivity, and even, of course, the power supply for the power line cases. But you can also have those on coax, again, because G.hn, it can be used on any wire depending on the infrastructure, and that's the beauty of this technology. In some cases, that gets provided on coax lines, and for some other use cases on phone lines. So the most interesting thing about the technology is that can capitalize on the robust backbone. Being a wired connectivity over any of these wires, the connectivity, of course, it's robust use case. And then that is bundled with the Wi-Fi, because all users actually need freedom. They can move around in their house, around the house, in the garden, in the multi-dwelling unit, on the different floors of covering hospitality, offices, schools type of topologies. So that's coupled in the same device. The G.hn devices are actually providing the G.hn wired backbone and the Wi-Fi connectivity in the same device. They are called extenders. Got it.
So a lot of our audience would be internet service providers. A lot of people that tune into this are customers ourselves, or the customers of ours are internet service providers. So one use case that I thought was very interesting would be something like an MDU. So you've got, let's say, an ISP that wants to run a broadband connection to a apartment building, some other kind of MDU. So they can get the service, let's say, via fiber, or like you mentioned, even fixed wireless, but then they can use the existing wiring in that building and not have to rewire anything. So describe a little bit more how that works. So I'm assuming they use their traditional technology to get the broadband to the building, and where do they go from there? What else do they do from that point?
Exactly. You need to figure out where the entry point is, and you have the broadband connectivity provided to the multi-dwelling unit, either through a fixed wireless access point, either through a fiber, what we call fiber to the building, fiber to the curb. So that fiber to the distribution point, that actually stops somewhere in most of the cases, is not able to reach what we call FTTH, the fiber to the home, precisely. In many cases, and those cases are actually estimated to be between 10 and 20% of the cases in any country, because by some reason, either a technical reason, because you need to extend the fiber all the way to users' homes in a multi-dwelling unit, all the way to every apartment, and that means drilling holes in walls, or it's a cost related to it, because for the very last mile, what we call the last mile, that can be 300 meters, 800, 1,000 feet, that is the most expensive segment of laying the fiber. So then also for historical reasons, we have seen cases in the very tall multi-dwelling units in some of the countries that the buildings are historically preserved. They are looking so nice that it's difficult to really get the owner permission to touch and destroy to some extent, right? With drilling the holes in the walls. Then the fiber, for all these reasons, cost, technical or historical reasons, have to stop somewhere. Whenever that stops, we call that fiber to the economical point, because it stops there for economical reasons, and we can reuse what's already installed. And that can be coax, phone lines, and of course power lines. But for the larger distances, what we call the last mile, what it really makes sense for this use case is phone lines and coaxial lines. So the fiber then gets connected from the distribution point taken over the G.hn lines, the existing wires, and get that extended, the gigabit connectivity extended all the way to any user's homes. This is how the G.hn access topology works. And you can have then, of course, different flavors, because you can have multi-dwelling units topology, you can have the single family units topology in rural areas where you have a group of houses that are getting the fiber close to the distribution point. But then again, for the last mile, it's really very expensive for the service provider to get the fiber all the way to every single house, because that's a small group of houses. So it makes sense in all these different topologies to actually use what's already installed. And it's always phone line and coax, it's the cable that you find in the existing infrastructure.
So for the ISP, once they get to the building, is there some special equipment that they need to concentrate the signal in, and then they branch out from there? So what does the ISP need as far as their equipment? And then what about the customer premises? I guess there's little devices that plug in, but describe that for us.
Sure. You have what we call the GAM, which are the gigabit access multiplexers. They are working like headends in an access deployment. And you can have different flavors of the hardware design. They come in 4 ports, 8 ports, 16 ports, 24 ports, depending on the desired topology of the service provider. And they are installed in the basement of the building in some cases. They also come with reverse power feeding in case the CPE is needing to get the power from the installation, from the equipment itself, so that they can provide connectivity and power supply in the same time. So you have these big headends in the basement of the building, and then they can attach to it, a numbers of subscribers as desired, 4, 8, 16, 24, and then they come with the multi-masters type of hardware designs for attaching a bigger number of CPEs in bundle. And then what is important to understand that the software actually provides flavors for the different topologies. So the standard, the ITU G.hn standard itself, comes with different versions for the different topologies, whether that's point-to-point, point-to-multipoint, and then serving 16, 31 CPEs, and then even the standard itself for some topologies like industrial applications can serve up to 250 users, 250 nodes in a network on a multi-hop topology. So these are all the different hardware designs that are being provided by system manufacturers that are serving service providers topologies, depending on their needs, depending on the wire, depending on the topology, and the application that is customized for the use case.
So I'm assuming that there's some kind of security built in too. If you're sending the signal to different apartments in an apartment building, there's got to be some kind of security or encryption.
Yes, G.hn, ITU-T G.hn, by specification of the standard, it's AES 128 encryption, and then that also comes with the different software algorithms for different topologies as well. So when you have high density population in a multi-dwelling unit, so you can picture multi-floor building units, and then so many different apartments, so many different people on the same floor, all of them having so many different devices, because we all have 1 or 2 mobile phones, 1 or 2 tablets, and then the laptops and everything, and the smart TVs and the smart appliances in the home. So all that creates high density of devices. So then G.hn technology is able to master the optimization of that network using specific algorithms like neighboring domain interference mitigation in this case, which is able to modulate the signal, which is able to actually create cells of communication per connectivity, so that the network itself knows when a user, when a CPE is actually belonging to that specific network cell or not, so that the security is being preserved. And then the technology itself, the G.hn technology, provides point-to-point security, so that it has a unique key of encryption between two devices. So the key is not shared among all the nodes in the network, because if the key it's getting by some attackers and intruders, then that gets to actually affect the whole network. But it has a unique key between any pair of devices, so that's highly protected in the sense that can preserve communication one-to-one per link encryption, as we call it.
Okay, so there's technologies that have done the home networking side. Of course, there's Wi-Fi, but there's also MoCA, and there was HomePlug. Is this kind of overtaking the need for MoCA and HomePlug? Is that eventually not going to be needed with something like this?
No. Actually, HomePlug, we can talk a lot about that. I have been witnessing these comparisons, G.hn and HomePlug, for so many years. HomePlug was another alliance at the very beginning of the powerline communications. So we are talking about 15 years ago, that specific comparison, and it was before the creation of the ITU2 G.hn standard. It has addressed only powerline communications, the HomePlug. While ITU G.hn standard, it actually went beyond that when it became a standard to have powerline, then phone line, and coax and classic optical fiber by the means is the same specification. And then that for the HomePlug.
Yeah.
So HomePlug alliance as such has ceased to exist a number of years ago, when we went beyond with the certification of the ITU2 G.hn standard, and we went beyond addressing just powerline and incorporating different wires application to the same specification and to the same deployment. Now, when it comes to MoCA, is a different story, because MoCA technology exists and it is very well developed and deployed. So we are now looking into MoCA 2.5, MoCA 3.0. So that is a comparable technology for the coax application. So MoCA, as the name says, it is for coax deployments, while G.hn, it is for the ubiquity of the power line, coax, and phone line, depending what you wish to address. When you look at both technologies, of course, there are similarities, and on the home networking side, they both can address home networking applications, both MoCA and G.hn. And when you look at the broadband access, the same thing, both can access, can address the applications on the broadband access. So you have MoCA access and G.hn access, and so that's very similar. And then on the G.hn side, because it can also address phone line and power line communications, you can have other applications that can be addressed with these other wires, which can be industrial applications, can be smart meters for the IoT appliances. So different flavors that are actually coming and getting introduced from G.hn side because of the power line and phone line wires that are coming in addition to MoCA. But they are both great technologies.
And can you have some of these coexist in the same space? Let's say even with G.hn, where you have some power line devices and some running on coax, maybe some on the phone lines, can they intermix?
Definitely, that's a great question, Rick. The coexistence is being addressed at the ITU2 G.hn specification layers. It's one of the very first things the specification is looking into, those aspects when it's coming to deployment, because coexistence is highly needed at all levels, and especially in an infrastructure, in a home networking infrastructure, and also on the access side, when you have so many different technologies being deployed. So that's addressed by the standard itself. And then on the HomeGrid Forum side, we go beyond that to look into interoperability, which is then taking the technology to the next level so that service providers can actually mix devices from different silicon vendors, because G.hn ecosystem is actually having to complement these deployments with contributions from several silicon vendors. Same thing from the system vendors, because we have many members that are coming from the different topologies interests, again, addressing different needs of the market deployments. And they all need to not just coexist, but also interoperate. So the service providers, and not just the service provider, also electric utilities, which are other segments of end users that are actually deploying G.hn technology, they need to provide, they need to combine a mix of system vendors. So combining system vendors and silicon vendors, different flavors, can also only be ensured with certification. The certification is being provided by HomeGrid Forum authorized testing labs that are looking into compliance aspects and also into interoperability aspects. So compliance with the ITU G.hn standard to start with, and then interoperability at the application layer between the different devices that are addressing different topologies. So that's not just highly important, but it is critical for the successful deployment of service providers.
Mm-hmm. So, Wi-Fi obviously has been around a long time, and there's a lot of buzz about Wi-Fi 6 because of the speeds and some of the improvements in that. So, Wi-Fi 6, you guys don't see it as competitive. You see it as Wi-Fi is complementary to this, right? For home networking, even.
Excellent point. Yes, I have been witnessing that question also over decades, if not more, as well, because when G.hn technology started to get deployed in full force, we had the initial certified devices back in 2008. Of course, it was a very legitimate question from the end users and service providers. How does that compete, and how well the performance can be compared between Wi-Fi and wired connectivity? Well, we have been looking into those aspects and dealing with performance testing at all levels between the system vendors and the silicon vendors for so long. But the good news is that already 8 years ago, when we had the very first devices certified with both the technologies, wired and Wi-Fi, it was when service providers came to the conclusion that, and I like to say that a lot, there is no single technology that can address any topology, and we all need to understand that. So wired connectivity does provide the robustness of a connection. Why? Because we have a wire already connected, already in place with the highest performance that a standard can provide. Mm-hmm. But then we also need freedom of movement, mm-hmm. and the freedom of movement can only come with the Wi-Fi connectivity, the latest version of that, right? So now we're, of course, talking about Wi-Fi 6. These are two different words, apparently, that they have to combine and capitalize on each other's strength. When you wish to have freedom of movement and still very robust connectivity, able to support you on high definition for HD, HD streaming, multi-room, multi-screen, video, online gaming, and then all the different applications that are required with very high, precise connectivity, like for the surgeons, for the robotics, for the 4th Industrial Revolution. There is no mistake that can be accepted in this connectivity. It's not like I'm getting an email late, right, and there is a latency when I'm talking to you. Some applications are really critical for getting this highest speed and lowest latency in order to make sure they, like healthcare, right, surgeries and so on. Mm-hmm. So it is critical to have the best of the two worlds, and what HomeGrid Forum members have provided, developed, and deployed since then were devices that are having both Wi-Fi, the latest Wi-Fi version available at that time, and then one of the cables, either Wi-Fi powerline devices, either Wi-Fi coax devices, either Wi-Fi phone line devices. Mm-hmm. And that's transparent for the users. actually they can connect their devices, their laptop, their tablets, their IoT devices to the access point, which does have the Wi-Fi, but then the connectivity is actually wired. The backbone is being provided by the G.hn.
Mm-hmm. So I just thought of a use case. I'm going to throw a curve at you here. So you're familiar with 5G, and there's millimeter wave 5G where you've got very short distances and you need line of sight from the 5G access point to the CPE. So it tends to be in more dense markets, and this line of sight is an issue because millimeter wave won't go through walls. So the way that they're handling that now is they have an antenna on the home and they drill a cable like you would with satellite. They drill a cable through the wall, or I think it's Verizon has a two-piece antenna where they've got one piece that sits on the window and then the other piece sits inside the window, and they transfer the signal through the home that way. But I could see maybe an application here where you could have your outdoor user receiver that's pointing at the 5G antenna plugged in outside and maybe somehow getting the signal in through the power line as opposed to having to drill through the house or, again, having two window units. Does that sound reasonable?
Very smart, yes, yeah. Yes. And we do have members that are actually using G.hn technology for that kind of application and technology of our members. Mm-hmm. So that's very smart indeed, because you can think of these different use cases that are requiring line of sight. And also, when speaking of the line of sight, similar to what we have for the Wi-Fi. So this, depending on the topology and the use case, you can actually capitalize on the need of the line of sight, or you can capitalize on the fact that you have the wall in between, and then you simply plug into the wall and you have the power line connectivity providing, so the power supply and the connectivity on the other side of the wall in the same time. Very smart.
Mm-hmm. Great. Okay. So if I'm just a consumer and I would like to use G.hn in my home, it may be complementary with Wi-Fi. Is there equipment out on the market that I can go get that and use that? Does my ISP need to be supporting that, or can I get it as an end user?
In some countries, the service providers are providing a pair of G.hn devices because they do work in pair. You have to have one connected to the entry point of the broadband connectivity, like to the gateway set-top box, and then one in any other room of your choice, or in any room that you wish to have the entire wire, the entire building connected. And in some of these countries, service providers are providing a pair of these G.hn devices, and then you can go and acquire additional ones, or you can simply go directly and get them from the retail shops. From the physical shops, they're available on physical shops in US, in Europe, in Asia, and they're also available in Amazon, Alibaba, in all these different online shops. They can be purchased.
Okay, well, this is really fascinating. I can see where this can really take off. So this is not your day job. Your day job is MaxLinear, right? So you work for MaxLinear in kind of a similar role. Why don't you tell us about that?
Indeed, I have been working for MaxLinear Semiconductors for a long time. We have been engaged in the HomeGrid Forum also for 15 years, and we are supporting, and that's actually my role, to support service providers, customers of MaxLinear, to deploy G.hn security and to deploy G.hn technology in a secure and safe site to the highest connectivity requirements, to make sure their requirements are captured from a very early phase in the connectivity, because they are launching RFQs, RFIs, they work with system vendors, they are providing their high definition of the product at the very early phase. So that's highly important to have those requirements captured by the G.hn ecosystem. And that's something that I combine very nicely with MaxLinear job and my involvement at the HomeGrid Forum level. Mm-hmm.
So if a service provider wants to learn more about HGN, do they go to the HomeGrid Forum site, or how do they do that?
Yes, I would encourage them to visit the HomeGrid Forum website. Mm-hmm. And we have different sections that are addressing the different topologies for the home networking side, for the broadband access, as we said, also for the industrial use cases, from many white papers that are being used for explaining how the topology can be exploited and how the technology can be built on in order to address all the requirements of the different markets. As I said, the topology, it is driving the deployment in any of these cases. The wires are always there. The infrastructure does exist. The system vendors have been able to already deploy so many different hardware flavors of the G.hn technology, and with a special software that is addressing the requirements per topology. And the devices are being certified. They have been certified, many of them, and system vendors are coming on a daily basis to require different devices that they need certifications for interoperability. And we do encourage all the service providers interested to learn from the existing experience at the HomeGrid Forum members to join, to contact us and get their questions shared. We have a council of service providers that is willing to share all the different experiences they had with the G.hn deployment, so we are ready to help.
Great, okay. Well, I don't see that we had any questions today. I forgot to mention that people could answer or could ask questions via YouTube, although I did send that out in an email. But if you're watching this recorded and you have questions, you can feel free to just type that in the YouTube comment section, and I'll make sure I get that to Livia, and I'll get you an answer via YouTube. We can do that. So, Livia, thank you so much for joining us. I appreciate it. This was very educational for me, and I hope those that have been watching. This sounds like a great technology. I could see where we could help some of our customers that are maybe looking at how they can reach an MDU or some MTU, some other kind of apartment buildings, office buildings, resorts, those kinds of things. So we'll certainly stay on top of this technology. It sounds great. So hope everybody enjoyed this. Go ahead, if you did, please give us a thumbs up on the video, and you can always subscribe to our channel if you're not already. If you do subscribe, please click the bell. And when you click the bell, you'll be notified anytime that we post a video that I'm live. And I am live every week at 3 o'clock every Tuesday. So thanks again, Livia. Appreciate you joining us today, especially from far away Spain. I know it's a lot later there than it is here, so I appreciate that.
Thank you so much, Rick, for having me.
Yeah, you bet. Thanks, everybody, and I will see you next week. Bye-bye.